In this problem, we have piping structure, and it is subjected to several forces, but it is only supported by one fixed support at point A, and we need to determine the support reactions at point A. So again, the coordinate system is given. We start with drawing the free body diagram. And mark out the already known applied forces. And then we have a force right here. And now we need to sketch out the unknown support reactions. And because we have a fixed support at point A, which provides maximum constraints, it prevents translational motion along all three axes, and also it prevents rotation about all three axes. For that reason, it provides all 6 support reactions, namely the force along the x direction, the force along y direction, and the force along the z direction. But also the moment about the x-axis, the moment about y-axis, and also the moment about the z-axis. And again, we have one 3-dimensional rigid body free body diagram, which enables us to solve for maximum of 6 unknowns, and that's exactly what we have. So now we're ready to write our equilibrium equations. We have resultant force along the x direction, which has ax, as well as the 400 Newton, but that is along the negative x direction, and that equals to 0. Resultant force along the y direction, we have ay, as well as the 500 Newton force, and that's it. Resultant force along the z direction, we have az minus the 600 Newton force. And then resultant moment about the x-axis, we start with mx, that is our unknown moment support at point A. And let's look at what other forces have moment about the x-axis. The 3 unknowns ax, ay, and az don't have moment about the x-axis. That is actually why we choose the origin of the coordinate system to be at point A, so that we can eliminate those forces, these unknown forces, in our moment equations. So let's look at them one by one. The 400 Newton force is parallel to the x-axis, so no moment. The 500 Newton force is creating clockwise rotational effect with a moment arm of this much, and that is 0.5 meter plus another 0.75 meter, so that is 1.25 meter. And then the 600 Newton force, it also has moment about x-axis. It's creating clockwise rotational effect with the moment arm of 1 meter. So that's negative 600 times 1. And that's it. That equals to 0. Moving on to resultant moment about the y-axis. First, we have our unknown. And then look at the 3 forces one by one. The 400 Newton force does have moment about the y-axis. It creates a clockwise rotational effect with a moment arm of 0.75 meter. And the 500 Newton force is parallel to the y-axis, no moment. The 600 Newton force does have moment about the y-axis. It's also creating a clockwise rotational effect with a moment arm of this much, 0.75 meter, and that equals to 0. And lastly, resultant moment about the z-axis. We start with our unknown mz, and then if we look at the 3 forces one by one, the line of action of the 400 Newton force passes through the z-axis, so no moment. The 500 Newton force also has line of action passing through the z-axis, no moment. The 600 Newton force is parallel to the z-axis, therefore no moment about the z-axis as well. So that's it. That's a big zero right here. So from here, 6 equations, 6 unknowns, we can solve for all of them. From the first 3 equations, we can solve for all the forces. So AX equals to 400 Newton, AY equals to negative 500 Newton, and AZ equals to 600 Newton. And then these equations, they only have one unknown anyway, so from the next equation we can solve for mx to be 1225 Newton meter or 1.23 kilonewton meter. My from this equation, that's 750 Newton meter, and lastly mz is 0. As you can see, when I draw the unknown support reactions out in the free body diagram, I already draw them according to their conventional positive direction, so that when I solve for the unknowns, I can easily interpret the directions of all these support reactions.